Hello everyone, welcome to our channel and I'm so excited to have you here. Today we are starting a new series on aptitude where I'll guide you step by step to master different topics. In this series we'll explore various topics in aptitude, breaking them down step by step. Today we are starting with one of the most fundamental concepts, which is ratio and proportion. So what exactly ratios and proportions? A ratio is simply a comparison of two quantities. It's a comparison of two quantities. For example, if I say I have 10 apples and 20 oranges, the ratio of apples to oranges is 10 is to 20, or we can simply write it down as 1 is to 2. A proportion is a comparison of two ratios. For instance, if I say that 2 is to 4 equals to 3 is to 6, then we say that we are dealing with proportions. So it is essential to know about what actually a ratio is and what actually a proportion is. There are different types of ratio and proportions, which are finding the proportions, comparisons, share problems, increased percentages, the sum or a difference ratio, boys and girls, ages, coins, milk and water problems. So to solve any ratio or proportion problem, we need to know about a simple equation, which is A is to B equals to C is to D. Here B, C are called as means and AD are called extremes. So BC are means and AD are extremes. So we can write this equation A is to B equals to C is to D as A by B equals to C by D. So here A is called a proportion, B is called a proportion, C is called a proportion, and D is called also a proportion. This is the first proportion, this is second proportion, this is third, and this is fourth proportion. So total we have four proportions. Each proportion again have a formula. So we'll discuss the formulas in the next slide. As I said earlier, there are four proportions, which are A, B, C, and D. Each proportion again have an individual formula, where A equals to BC by D. And second proportion B is also called as mean proportion. So this is given as root of AC. Third proportion C equals to B square by A. And the last proportion, fourth proportion, is said to be BC by A. So these are all the four proportions which are available in ratio and proportions. Based on this, we'll solve the problems. Find the second proportion of 9 and 16. We just learned that second proportion is also called as mean proportion. And formula for mean proportion is root of AC. Here 9 is A and 16 is C. Root of 9 into 16 given as root of 144. We know the value of 144, right? It's 12. So the second proportion of 9 and 16 is 12. Moving on to the next question. Find the third proportion of 16 and 36 is dash more than 70. Okay, we need to solve this question in two steps. The first step is finding the third proportion, and the second step is finding the result is dash more than 70. We know the third proportion C equals to B square by A. Here 16 is A and 36 is B. That gives us 36 into 36 divided by 16. There is a possibility of cancellation. For 4, 16, for 9s, 36. Again for 1s, for 9s. So it's equals to 81. So the third proportion of 16 and 36 is 81. 81 is dash more than 70. It's 11, right? So 81 is 11 more than 70. We know that fourth proportion is D, and D is given as BC by A, which implies this is A, this is B, and this is C. So 5 into 15 divided by 3. 3 ones, 3 fives. So 5 fives are 25. So the fourth proportion of 3, 5, and 15 is 25. Next, you guys try this problem and let me know the answer in the comment box. And the last question for finding the proportions. The mean proportion of A and B is C. Okay. What generally we know mean proportion means second proportion. Second proportion is written by B equals to root of AC. But what they are saying, the mean proportion of AB is C, which means that C equals to root of AB. This can be written as C square equals to AB. Now, what is the mean proportional of A square C and B square A? So they are asking what is the mean proportion of A square C and B square C. So we can write it down as A square into B square into C square. Thus we cancel the squares and the square root. We get ABC. We already know that AB equals to C square. So we simply substitute AB with C square and the C. So the resultant will be C cube. And we have an option called C cube. Thus, for this question, the answer will be C cube. Next one. Okay, the next model is ratio comparisons. In this section, we compare the ratios to find the values of quantities. So general questions in this model looks like if x is to y equals to 2 is to 3 and y is to z equals to 4 is to 5, then they ask us to find the ratio of x to z. So to solve these kind of questions, what we just need is simply note down the given ratios. 2 is to 3, 4 is to 5. Now what we need to do is multiply. Multiply with 4 and here multiply with 3. Okay, multiply with the last term and multiply with the first term. So what we get, 4 2s are 8 and 4 3s are 12. Here 4 3s are 12 and 5 3s are 15. So which means 8 is to 12 is to 15. So this is x, this is y and this is z. Now we know, right, x is to z ratio which is 8 is to 15. So these are the questions which we face in ratio comparisons. Moving next. So this question you try it on yourself and practice some more questions related to this kind of model. Next question. If 4x equals to 5y and 6y equals to 7z, find the ratio of x is to y is to z. Okay. If we analyze this problem carefully, we can know that it's saying that x is to y equals to 4 is to 5 and y is to z equals to 6 is to 7. And we know what to do now. So we just simply multiply with 6 here and we multiply with 5 here. What we get? 24 is to 30 is to 35. So this is the ratio of x is to y is to z. Looks simple, right? Yes. Moving forward. Compare the ratios 3 by 7 is to 5 by 9 and find which is larger. I'll say a simple trick for this question. So they're asking us to find the thing which is larger. So just simply note down the given ratio as it is. 3 by 7 equals to 5 by 9. What we need to do is simply cross multiply. What we get? 9 3 is 18 and 7 5 is 35. Now you compare which is larger. 18 is larger or 35 is larger? Of course 35. So the ratio is also 5 is to 9 is larger. Looks easy, no? Yes. Next question. Two numbers are in the ratio 7 is to 9. The larger number is 72 and find the smaller number. So here they gave two numbers but not numbers directly. So they gave that numbers are in the ratio of 7 is to 9. And they gave a hint that the larger number is 72. And they're asking us to find the smaller number. Okay, let's write what the data is given. So they gave that ratio is 7 is to 9. And they said that larger number is 72. So among the 7 and 9, what is larger? 9 is larger. So what we do at the place of 9, we find 72 and we need to find a smaller number. Again, simply cross multiply. 9x equals to 504, which means x equals to 56. So 56 is the smaller number, 72 is the larger number. Next question. Okay, next model. The next model is about sharing and dividing. This section is generally divided into two types, which means a normal way of sharing the ratios and the quantity. And the second thing is by mistake, the original ratios are divided into another ratio. So we need to find the difference between these two problems. Divide 6,000 among A, B, and C in the ratio of 2 is to 3 is to 5. They said they have given a ratio and they have given amount. So they're asking us to divide the amount among A, B, and C in the ratios 2 is to 3 is to 5 respectively. Okay, first we'll note down the ratios 2 is to 3 is to 5. So we need to remember that these are the ratios but not the values. So we always need to consider them as 2x, 3x, and 5x. These are always considered to be with x. And what they are saying, all these ratios will become equals to 6,000. So when all the ratios becomes equal to 6,000 means we need to add them. 2x plus 3x plus 5x equals to 6,000. So this is a sum of 10x. 10x equals to 6,000, which means that x equals to 600. Okay, we just now found x, but we need to find what is the share of A, B, and C. They're given that A is in the ratio of 2x. So how much A gets? 2 into 6, 1200. How much B gets? 3 6 are 1800. And similarly, C gets a ratio of 5x, which means that he gets 3000. up. This all sum ups and becomes 6,000. This is a way of solving ratios when they are given a total quantity and respective ratios. Moving on to the next question. A total of 119 is shared among 3 friends. Okay, a total quantity is given and it's shared among 3 friends such that the ratios are in the ratio 1:1 by 4:1 by 6. An important point here to remember is ratios can never be in fractions. Ratios can never be in fractions. What we need to do is we need to convert the fractions to numbers, fixed numbers. How can we do it? By taking an LCM. LCM of 4 and 6 becomes 12. So 12 is to 3 is to 2. So a 12 gets cancelled always and we find a ratio as 12 is to 3 is to 2. So this is the ratio. Now we need to divide 119 in this ratio. We already solved last problem same kind. So this is simple. Now what we do is 12 plus 3 plus 2 equals to 17. We need to consider it in x. So 17x equals to 119, which means that x equals to 7. Now we can find each share, right? How much A gets? He gets 12 into 7. That is 84. Similarly, we can calculate for B as well as C. So it was decided that sum of 780 is shared among P, Q and R in the ratio of 1:3. But by mistake, it was divided in the ratio of 1/2 is to 1/3 is to 1/4. Okay, this is a second model where ratio is divided by mistake. Initially, we'll note down the given ratio 780. And we'll divide this into 2 parts, which is original ratio and mistaken ratio. Original ratio is in the form 1:2:3. And the mistaken ratio is in fractional part. We'll convert it to the fixed integer. The LCM becomes 12 and the ratio becomes 6:4:3. So the ratio becomes 6:4:3. So this is the original one and this is the mistaken ratio. Now what we do is adding x and then adding each part. 3 plus 2, 5. 5 plus 1, 6. 6x becomes 780 and your 13x becomes 780. Cancellation possible, right? So 6, 130 and here x equals to 60. X equals to 130, x equals to 60. Now we'll substitute this x in the original ratio. What we get? 130 is to 260 is to 390. And here what we get? 6x into 60, which means 360 into 240 into 180. So these are the ratios which we got. So the question is, what was the loss of Q in share due to this mistake? So what was the loss of share? This is P, this is Q, and this is R. P, Q, and R. We can find out that initially P should get 260, but when it's mistakenly taken, he gets only 240. So what's the difference between them? 20 rupees. So he got a loss of 20 rupees. So this is the way of solving this kind of problems. Moving to the next question. This question you try it on yourself and let me know if you have any doubt. I'll help you in solving this. Next, the next model is increased percentages. The most simplest model among all the ratio and proportion is increased percentages. Why? Because you know the same formula is used for every problem. Let's see first problem. The number of books on mathematics, physics and chemistry in a university library is in the ratio of 8:5:9. There is a proposal to increase the books by 10%, 5% and 5% respectively. What will be the ratio of number of books after an increment? So a ratio is given and a percentages which are said that they are going to increase. So this is why these problems are named as increased percentages. It's a simple thing. All the models in this type of increased percentages can be solved in only one short line. What to do is initially write down the percentages 8, 5 and 9. So what we think generally a percentage is about 100. So anything we calculate from 100 only. So it said that 10% increase. A 10% of 100 becomes 110. So what we do is 8 into 110 is to 5 into 5% of 100 is 105. So 5 into 105 is to 9 into 105 again. So this is the way of calculating a single line can calculate increased percentages problems. Now we can cancel them using a 5 table. So this can be cancelled 22 times and this can be cancelled 21 times. This is also 21 times. Now 8 into 22, 176 and 5 into 21, 105 and 9 into 21, 189. This is the ratio. So this is what we need to find. They asked that what will be the ratio of number of books after increment. So after increment, the ratio will be 176 is to 105 is to 189. Simple problem. So again, next question. Number of seats for mathematics, physics and biology in a senior secondary school are in the ratio of 5:7:8. So a ratio given and there is a proposal to increase the seats by 40%, 50% and 75% respectively. The same model will solve it. So 5 into 100 plus 40, 140 is to 7. 7 into 50% increase means 150. Next again 8. 75% means 175. There's a possibility of cancellation which is 28 times. This is 30 times and this is 35 times. So the final ratio will be 140 is to 210 is to and 8 into 35 becomes 280. I think again there is a possible way of cancellation. let's cancel the zeros first, and 7 2s, 7 3s, and 7 4s. So the final ratio will be in 2 is to 3 is to 5, 4. So the ratio of increased seeds is 2 is to 3 is to 4. Looks very, very simple, no? So all the increased percentages will be in same model. And you guys try this problem. The next model is sum or difference ratio. Here in this model, we may find either a sum is given in the question or a difference is given in the question. Based on the sum and the difference, we'll find out the solutions. So, first question, if two numbers are in the ratio 5 is to 7 and the sum is 120, find the two numbers. A sum is given and saying that two numbers are 5 and 7. These are not values, these are the ratios. So, we need to consider them as 5x and 7x. Then they are saying that their sum is equals to 120. Simple to form an equation. A sum of numbers equals to 120. 7x plus 5x becomes 12x. 12x equals to 120. Then x equals to 10. If we know the x value, we can easily find out the numbers. 5x means 50 and 7x means 70. So 50 and 70 are the two numbers. Next question. The sum of two numbers is 40 and the difference is 4. So a sum is given, a difference is also given, but a ratio is not given. But simply we can assume that one is x and the other is y. So it said that a sum of numbers is 40 and the difference of numbers is 4. Since childhood we are solving these equations. 2x equals to 44, x equals to 22. By substituting x in either of the equations, we get y. Y becomes 18. So these are the two numbers. Next question. There is a ratio of 5 is to 4 between two numbers. If 40% of the first number is 12, then what would be the 50% of second number? Okay, they again didn't give any values, but they gave a ratio of the numbers, which is 5 is to 4. And they're saying that 40% of the first number is 12. What is the first number? 5. So 40% of 5 is 12. Or 40% of 5x, not 5 alone, okay? 40% of 5x becomes 12. And we can calculate them using percentages. 5x divided by 100 into 40 equals to 12. We can cancel the 0 here and 5 ones, 5 2s. That implies 4x equals to 24. Again, x becomes 6. When we find that x equals to 6, we can find the values first. 5 6 are 30 and 4 6 24. These are the original values. What they are asking, what would be 50% of second number? What is the second number? 24. 50% of 24 becomes 12. Thus, 50% of second number is 12. Moving next. For three numbers, the ratio of first, second is 2 is to 3 and the second and the third is 4 is to 5. If the sum of three numbers is 140, then what is the second number? So, are you remembering anything? This is the kind of comparison problem where they are saying that ratio of 1 and 2 and ratio of 2 and 3. What we need to do? We need to find a ratio of 1 is to 2 is to 3. Okay, let's write down the given ratios. 2 is to 3 and another ratio is 4 is to 5. We know what to do. Multiply with 4 here, multiply with 3 here. What we get? 8 is to 12 is to 15. This is the ratio which we get. Now what we do? Replace x. After replacing x, we need to sum up all this because they said that sum of three numbers is 140, which means that 8x plus 12x plus 15x equals to 140. 15 plus 12 plus 8 becomes 35. 35x equals to 140. By doing cancellation, x becomes 4. So x equals to 4. what we need to find then, what is the second number? So we need, this is the first number, this is the second number, and this is the third number. Second number is 12x, which means that 12 into 4. 12 4s 48. So 48 is the required second number. So far we have covered many models and different questions. So this is all about part 1. This is just a part of our journey through ratio and proportions. In part 2, we'll tackle more advanced models like ages, milk, ratios. Until then, I encourage you to practice the problems we discussed today and challenge yourself with similar ones. So stay tuned for part 2. If you found this video helpful, don't forget to like, share and subscribe to our channel for more such content.